Okay, now let's see some of the questions related to chapter 20, petrochemicals and polymers. I will give you some tricks and tips how to handle these questions from the chapter 20. Okay. Now let's see the first question. Which statement about monomers or polymers are correct? To answer this question, you have to remember three main concepts related to monomer and polymer. First of all, you must know the difference between monomer and polymer. Monomer is the smallest unit, okay, that makes up or they join together to make a polymer, whereas polymer is the largest unit that has millions or hundreds of the monomers joined together. Okay, that is the first concept you must know. And how you will know? You can see it from the word polymer. Can you see the word polymer? Polymer means multiple, right? So it is a compound that is made up of millions or hundreds of the monomers. Okay, now let's see, come towards the second point. The second concept you have to memorize is that polymers can be made by two types of reaction. One reaction is addition reaction, in which the same monomers will join together, especially those monomers will belong to alkene group. We're having a carbon-carbon double bond. Okay, so addition reaction will result in the polymers that are called addition polymers, and one of the example is polyethylene or polypropylene. Okay, so polymers can be made through addition reaction, or another reaction is condensation reaction. What is the difference between these two reactions? In addition reaction, you will get only one product from the joining of the monomers. Okay, you will get just one polymer. But in condensation reaction, you will get a polymer and also a small molecule, that is water. Okay, whenever two monomers will join, you will get one water molecule. So if millions of monomers will join in the condensation reaction, you will get millions of water molecule. Okay, remember this one. So there are two reactions that can give you polymers. One is addition reaction and the other one is condensation reaction. And other important concept you have to memorize is that the polymers can either be made up of same type of monomers, or they can be made up of different types of the monomers. Okay, so now we will see one by one these options and we'll check which options are right. The answer is already given over here, that is option C, but we can check now one by one. Monomers are always joined together by addition reaction. Addition reaction is right, but always is not right, because they can also be made through condensation reactions. So option 1 is incorrect. Second, a polymer can be formed from a single type of monomer. Yes, a polymer can be formed from a single type of monomer, or maybe two different types of the monomers, okay, or maybe multiple types of the monomers. So that's option is right. A polymer can be formed by joining two different types of monomers. Yes, I already have informed you. So option 3 is also right. So that's why option C is correct. 2 and 3, both options are right. Let's see for option 4. Water is always produced when monomer molecules join together. That is wrong. In addition polymerization, water is not produced. Okay, it is only produced in the condensation polymerization, but they have not mentioned about the condensation polymerization. So this option is also not correct. So we are only left with option 2 and 3. So that's why the option C is the correct option. Now let's see another question. Which structure represents the repeat unit of addition polymer from butene? So to understand the structure formula of any polymer, you have to first check that which one butene represent, how many carbons butene should have. Now, so for this one you have to memorize some concepts like methane, MET, it will always have one carbon. ETH, then it means it has two carbon. And this BUT, if you see the word BUT, the starting word of any hydrocarbon or organic compound, it means it has 4 carbon in it. Okay, so you see all of them have 4 carbons in them. But to make a polymer, remember that the butene, because it belongs to alkene group, it has carbon-carbon double bond, so it is the main component of addition polymerization. So whenever addition polymerization will take place, there will be only one carbon-carbon double bond in one monomer, right? So the carbon-carbon double bond will make actually the main chain of that polymer. So if you see, the carbon-carbon will make the main chain, so you will only see 2 carbons of each monomer. Okay, so one monomer will have only 2 carbons, and the remaining carbons will be as a part of side chains. These 2 carbons will be the carbon that are having a double bond. Okay, so can you see here we have 2 carbons, here we have 2 carbons, right? So these two can be the right option. These options are not right. Why? Because in main chain, if you see, you have 3 carbons. But for addition polymerization, the monomer should have only 2 carbon in the main chain. The remaining carbons should be in the side chain. So 2 are here and the remaining 2 are on the top, right? So 2 are here and the remaining 2 are on the top. So these two options are right. They both are butene. But if you see the name, butene is but1ene. What does it mean? It means that carbon-carbon double bond is present on the first carbon, or you can say between first and second carbon. So this option can only be the right option. Why option A is right? Because the first carbon and the second carbon has the double bond, and then this carbon has the side chain. Okay, so this is the first carbon, this is the second carbon, and the remaining carbons are on the side as a side chain, okay, are represented. So that's why option A is correct. Why not option B? Because if you just count from here, this is the first carbon, then second, then this is third. So it means the double bond is present between second and third carbon. So that's why option B is not right, because this is butene 1ene, not butene 2ene. Okay, but 2ene. If it was but 2ene, then option B was the right one. But now option A is the correct option. Let's see another question related to the condensation polymerization. Now let's see. Okay, so in condensation polymerization, I already have informed you that there will be a polymer, and also you will get a small product that will be usually a water molecule. Okay, in your book it is given as a water molecule, so it's simply your answer should be water molecule. But if you just want to be sure about that one, you can see over here the what are the functional group on each of the monomer, because mostly the condensation polymers involve more than one type of monomer. So this is the first monomer, and it has 2 functional groups. If you see over here, COOH, and this is the functional group of carboxylic acid. So this monomer is actually a dicarboxylic acid because it has 2 monomers, 2 functional groups, right, on both the side of its chain. If you see this monomer, it has 2 amine group. What is amine group? NH2. So this functional group is amine, right? So it has 2 functional group that are amine group, right? So this monomer is actually diamine, and this one is dicarboxylic acid. So now carboxylic acid always lose OH, because the water molecule is made up of OH ions and hydrogen ions, right? So OH ions are always given by carboxylic acid. You can see over here OH, and here you will get hydrogen. So hydrogen will be released by diamine. So when they join together, you will get a water molecule. So that's why a small molecule that is released during condensation polymerization is water. Okay, so option A is the right option. Let's see another question. The structure of the part of a polymer is shown over here. How many amide and ester linkages are included in this structure? So to answer such question, you must know what is ester linkage and what is amide linkage. I already have explained you the ester linkage in chapter 19, that esters are formed when carboxylic acid and alcohol react with each other. So alcohol will lose its hydrogen, you can see over here, and carboxylic acid will lose its OH. So the remaining will be only CO, because carboxylic acid functional group is COOH, right? So one OH has been removed, so the remaining is only CO. So COO is actually an ester linkage. So how many CO you can see over here? You can just see one CO, right? Here it is, we don't have another O. So this is the only linkage here. So now we have only one ester link. Can you see here? So B or C option can be right. Now let's come towards amide link. What is amide link? Amide link is formed when a diamine and a dicarboxylic acid react with each other. We get amine group. Okay, so in amine group, amide link will be formed. How the amide link will be formed? That amine will release its one hydrogen. What is amine? NH2. Okay, so can you see here that we have NH, and one H has already been removed to give you a water molecule, whereas the carboxylic acid will remove its OH, right? So CONH is an amide linkage. Can you see how many NHCO we have? NHCO1 and NHCO. This is a second one, right? So we have two amide linkage and one ester linkage. So our answer C is the right option. Let's see question 133. Parts of structure of two different polymers are shown here. Which row about the monomers and the linkage between the monomers in the polymer X and Y is correct? Let's see first the linkages. The linkages between these two monomers. Can you see we have one monomer here and this is the second monomer. Usually in condensation polymerization, we represent the monomers like in a form of a box, right? Because we are not interested what is inside that box, what is the chemical formula inside the box. Okay, we are just concerned about the functional group it has. So the functional group are mentioned here, right? Can you see the functional group here? This is CO, the functional group here, right, on the both of its side. But if you see here for this monomer, it has NH and NH. That is the functional group for this monomer. So how many monomers we have? Two monomers, right? This one also have two monomers. Now let's see, are these two monomers similar or different? They look similar, but you have to be very careful when you are looking at the functional group. If you look at here, these monomers have two functional groups that are similar. Can you see carbon double bond O and carbon double bond O? What does it mean? It means it was dicarboxylic acid, right? It is dicarboxylic acid. But if you look at here, this monomer has carboxylic acid on one side, but on the other side it has amine group. So what does it mean? It means it is not a dicarboxylic acid. It is actually an amino acid. Amino acid is a monomer that has one amine on its one side chain, and on the other side it has the functional group carboxylic acid. That's why we call it is amino acid, because it has amine group also and also carboxylic acid group. So this is actually amino acid and this one is dicarboxylic acid. This one is what? It is actually diamine, and this one is what? This is also an amino acid but of different type, right? So because the inside structure is different but the functional groups are same of these two, right? So X and Y, the monomers are now not the same because this monomer is dicarboxylic acid, this one is diamine, but this monomer is amino acid. So the amine monomers in X and Y are not same, they are different. So A and B option can be right. Now let's see towards the linkages. The linkages are always same for diamine and dicarboxylic acid when react or when amino acids react, because amino acids also have a functional group carboxylic acid and amine group, right? So the linkage will be the amide linkage. So can you see here the linkage is same, C double bond O NH, and here the linkage is also same, C double bond O NH. So the linkage is same. The linkage in X and R are the same as that, the linkages in Y. So option B is the right option. Let's see, what is the structure of PET? Okay, so before I explain you the structure of PET, you have to memorize about the two condensation polymerization examples. Okay, so we have two types of condensation polymerization. One is PET or polyester, we can call them polyester, and the other ones are polyamide. Okay, what are polyesters, what are polyamide? That is the difference is only between the linkage. If the linkage is ester linkage, then such polymer is called ester, polyester. Okay, if the linkage is amide linkage in that polymer, then we will call it a polyamide. So what is ester linkage and what is polyamide link? The amide linkage. Ester link is formed, it is obvious from the name. How esters are formed? They are formed when carboxylic acids react with alcohol. Okay, so when a diol, a dialcohol and dicarboxylic acid react, these two monomers, when they react, they make a polyester, releasing a water molecule, right? So polyester will have a ester bond. PET is an example of polyester polymer. Okay, polyester polymer example is PET, and another name for PET is terylene. Okay, so in exam, if you see the word PET or terylene, it means they are asking about polyester. So this is one of the examples. So polyester link is C double bond OO. So you will have one carbon and two oxygen in that linkage. So can you see that linkage here? We have carbon double bond O but we don't have another O. So it means this is actually a amide linkage, not a ester link. So this one is an ester link. Can you see here? Yes. Again, we have ester link. Again, we have ester link. So C double bond OO is actually the ester link. So option B is the right option. Why not D? If you see here, this one is an ester link, but in the next one, we don't have the ester link, right? So this one is not PET. The example of the PET should be all the monomers are joined by a ester bond. So here we are missing the ester bond. So it means it is not PET. So option B is the right option. Now let's see nylon. Nylon is formed by condensation polymerization. I already have told you we have two types of condensation polymers. One are polyesters and the second one are the polyamide. So nylon is an example of polyamide. In polyamide, we have two examples. One is nylon and the other one is protein. So how nylon is made? Because the nylon is polyamide, so it means it will have which linkage? It will have amide linkage. And what is amide linkage and how it is formed? Amide linkage also have a same monomer like the ester, that is carboxylic acid. In esters and in polyesters and in polyamide, we have one monomer that is similar, that is carboxylic acid. But the second monomer is actually different. In polyester, we have the second monomer is actually alcohol, right? But in amide linkage, we have the second polymer, that is monomer, that is actually an diamine. Okay, a diamine, when react with dicarboxylic acid, you will get a amide linkage. Okay, so diamine is how NH2 actually is a amide linkage. So amide linkage, NH2 and CO, this is actually your amide linkage. And NH2, only NH2, that is amine. Okay, AMINE, not amide. So NH is actually amine. When amine react with carboxylic acid, it will give you amide linkage, AMIDE. Okay, so this is amine, and when it reacts with carboxylic acid, amine will lose its H, right? Can you see here? Now we have only one one H and then one nitrogen, but actually amine has two hydrogens, right? So one hydrogen has already been removed when the water molecule was formed. Okay, and whereas carboxylic acid already have lost its OH ions, so now it is left with only CO. So what is amide linkage? It is actually CONH. So can you see CONH? Yes, all of them have CONH. This one don't have CONH, so this is not a nylon. This one is CONH. Yes, it can also be nylon. And this one is COONH. So it means this is wrong. The amide linkages actually have only one oxygen, one carbon, one nitrogen, and one hydrogen. And carbon and oxygen bond is double. Okay, so that's why CONH is the right option. So which options are right? A or C can be right now. So I already have told you the amide linkage is present in two. We have two examples. One is protein and the other one is nylon. So how we can differ between nylon and protein? The main difference is that first you have to just look for the amide linkage. It will be same, right? They both have A and C have amide linkage, but one of them is protein now and the other one is nylon. How we can differentiate between that? You have to look for the monomer. Now just look at each monomer and check that what about the functional group on its sides. If the functional groups are same, then it means it's a nylon, okay? Because nylon is made up of dicarboxylic acid and diamine. But protein is just made up of amino acid, and amino acid has two different functional group on one monomer. Amino acid is a monomer that has two different functional group. One side has amine and the other side has carboxylic acid. Okay, so now let's see how many. Okay, if you see this one, this monomer, can you see this black and this gray box? So if you check at this gray box, okay, so on this side we have what? We have carbon double bond O. So it means it is dicarboxylic acid group, right? But if we look at this side, it has NH. So it means this monomer has two different functional group. On one side, it has carboxylic acid. On the other side, it has NH, right? So it means this is amino acid, and amino acids are joined together to give you a protein. It's not a nylon. So option C is the right option, Because if you look at this monomers have C double bond O, C double bond O, right, on both the sides. So both the functional groups are same, right? But if you look at the second monomer, it has also the same functional group, that is NH, on both of its sides. So that's why nylon should have two different monomers and each monomer should have a same functional group. So that's why option C is the right option here. Let's see now the example of the protein structure. So you already have known that it should have amide linkage. Let's look for the amide linkage first. Can you find the amide linkage? Which one has the amide linkage? It's simple. A and D has the amide linkage, right? So now which one of this one is protein and which one is nylon? Let's see. This one is nylon. Can you see this monomer has two functional group and both of them are same. So it means it's an example of nylon. Nylon has a monomer that has two functional group that are same, right? This monomer has two functional groups same. Then the next monomers has NH, right? So it means this is nylon. So the remaining one, the D, is actually your protein, because if you see this monomer has two different functional group. One is NH and on the other side it has C double bond O. So D is the right option. So whenever in exam you get the option of nylon and protein, first you have to look for the amide linkage so you can exclude the other options. So now here we have excluded B and C. We were left only with A and D option. Now after you are left with two options and both have amide linkage, then you have to look for the monomer. Which monomer have the same functional group? If one monomer has the same functional group on both of its sides, then it means it will be a nylon. If it has different functional group on both of its sides, then it means it will be a amino acid. So that's why option D is right over here. Let's see another question. Which structure represent the part of a protein? It's simple, so you can also check over here. And then which option is right? Of course, option A is right for the protein, because it has two different functional group on both of its monomer, right? And also it has a amide linkage, that is NHCO. Okay, so option A is the right one, whereas option C is right for nylon. Okay, A is protein and the C is actually nylon. Let's see question 138. Part of the structure of polymer is shown over here. Which statement about the polymer is correct? So first we have to look at this polymer. The polymer is nylon. We have to look for this one now. The polymer has a amide link. Yes, okay, that's right. The nylon has a amide link, but we also have to check that whether it is a protein or nylon. So if you look at this monomer has two different functional group, right? It don't have the same functional group on its side. So it means it's not a nylon. It is actually a protein. So option 1 is not right. Let's see the second one. The polymer is formed by condensation polymerization. Of course, proteins are formed by condensation polymerization. They release a water molecule when two monomers join. So option 2 is right. Let's see the third one. There are ester linkage between the monomers. Wrong. This linkage is actually CONH is amide linkage. So option 3 is also wrong. So which option we are left with? Only 2, right? So option C is the correct option.